Okay, we are recording. We're going to take the next step, and this is something that once you've seen it, and I've told you to do it, if you take notes and you go, always remember to do this, it works. But notice you don't have just a theta here or just an x. You got 4x or 4 theta. You'll have some number multiplied times that x in here. And you're wondering, well, how do I do that? Okay, I'm going to show you. You've already got the trig function isolated, and there's that part, right? Okay. Here's what I always tell students to do. Okay? This is what I suggest you do. Write theta equals 4x. You write that on your sheet, because you got to know that. Then you can write sine theta equals square root of 3 over 2. And why do you do that? Because now you can just look on your unit circle and find out what theta equals. Now, is theta what x equals? No, but at least it makes it easy. Just don't even worry about the 4x yet. Change it. And if they had 4 theta there, then I'd put x equals here, right? But you want a variable, and you want that. And then you need to label it, theta. And we're going to make a list of the thetas. And we're going to look on our unit circle. And what are the theta values that we need? We need what? Pi over 3. And then where else?
2 over 3 pi.
Okay. Now, here's the next step. Okay, so we've got that done. Now I'm going to tell you what makes this more complicated. Not really harder, but more thought. All right. Everybody up to this point? Everybody know how to get to that? Anybody can't find those on their unit circle? Talk to me.
Where did you look?
I looked on my unit circle for where square root of 3 over 2 is the y value, because those are the signs.
Okay.
And then I should have that written on my unit circle.
Okay.
Okay. Are you still using that same circle from the other day?
I redid it.
Sir?
I redid it and took off the stuff you told me to take off.
Okay, and you wrote it where you can read it?
Yes, sir.
Okay. Now, here's the next step. Did you put that little cosine comma sine thing that was supposed to be written at the top of it? So you did. Okay. Here's what you have to do. You have to add 2 pi to that. Now, remember, 2 pi would be what? 6 over what? 3. Is that okay? All right? You add 2 pi, so that's going to be 6 over 3, so that's going to be 7/3 pi. All right? Then you have to add 2 pi to this one. Oh, and I'll tell you why you have to do that. You have to do this when you have these numbers out front. Okay? That's what tells you to do what I'm about to do. Before, you would have just stopped right here. But when you see this number in front of the x, you have to go and add 2 pi to this first answer. And you get 7/3 pi. Then you got to add 2 pi to this. Now, when you're adding that 2 pi, get the common denominator, because 2 pi is the same thing as what? 6/3. So you're going to add 6/3 to that. What's it going to be when you add 6/3 to that? It's going to be what? 8/3. Notice a student that cannot add and subtract fractions is going to have a problem. Now, here's the catch. See, that's number 4 right there? You've got to do that 4 times. You got to do it. There's once. Then you got to add 2 pi to these. Add 2 pi to that one. Add 2 pi to that one. Then you got to do it one more time. See, you added it once, added it twice, added it 3 times, and then we're going to have to do it again because I did 4 pi. Why did I do such a big one? Okay, so you're going to add 13/3, so that's going to be 19/3 pi, comma, 20/3 pi, and then do it one more time. I'm counting how many times I go around the circle. You've got to add the 2 pi the same number of times as whatever that number is. Everybody see that? See where I'm getting the idea? Yeah, since that's a 4, I got to add 2 pi once, twice, 3 times, and one more time. 25 thirds. And add it to that, 26 thirds. Now, if you're having trouble with the fractions, go ahead and convert that to whatever you need for your common denominator right there, and it'll help you. And what do I know that I got to do it? How do I know I got to do it that many times? Because there's a 4, so I got to go around the circle 4 times. Went around once, twice, 3 times, 4 times. And as I'm making a video, I'm thinking, gosh, I might should have taught this before, because I really think you could have stopped right here and just gone around it 4 times. Went around it once, went around it twice, went around it 3rd time, went around it to what? 4th time, okay? You got to go around the circle 4 times. I just actually went around it how many times? 5. I'm going to show you what happens when you do that, though. Because used to, I just told kids, just keep going around the circle until you have all the answers. And they said, well, how do you know how far to go around it? I don't know, just keep going around it. But I'm going to show you how this works. All right, now remember, we're looking for the answers. We're looking for the solutions that are between 0 and 2 pi. Does everybody realize we're always looking between what? 0 and what? 2 pi. Okay. Is everybody okay with making that list? Take this number. And somebody said, well, could you add 2 pi here, then add 2 pi, and add 2 pi? You can, but then you have to skip spaces and you get them out of order if you're not careful. So I always do this one, and add to those, add to those. All right. Ma'am?
Can you say that again?
Yeah, these are my 2 that I got the first time I went around the circle, right? Then I added 2 pi to those. That's my 2nd time around the circle. Add 2 pi to those. That's my 3rd time around the circle. Add 2 pi to those. That's what? My 4th time around the circle. And how do I know I've got to go around the circle 4 times? Got that 4 right there. If I had a 2 right there, I'd only go around the circle how many times? 2. Okay? Is that all right? Yeah. Now, that's what theta equals. But I don't want to know what theta equals. I want to know what? What x equals. Is everyone okay that x equals 1/4 of theta? X equals 1/4 theta. If theta equals 4x, then x equals what? 1/4 of theta. So what am I about to do to all these in order to find the x value? I'm going to multiply them all by what? 1/4. Multiply that by 1/4, you're going to get pi over 12. Multiply that by 1/4, you're going to get 2 over 12. But what does 2 over 12 reduce to? 1/6. Then you're going to multiply that by 1/4. That's going to give you 7 over 12. Multiply that by 1/4. It's going to give you 2/3 pi. Okay? We'll put a little arrow there so that, yeah, multiply it by what? 1/4. Then we'll multiply this one by 1/4. That's going to be 13/12. Multiply that one by 1/4, 7/3, 4, 7, 6. Someone says that Mr. Evans, that number right there is wrong. 1/4. Yeah, no, that is right. Okay. 1/4 here. 2's divide out 7/3. Somebody said, Mr. Evans, you're always giving us a hard time about not being able to do fractions, and here you are having trouble. Yeah. Mr. Evans, can't believe you can't multiply 2. Here, 7, 6, 5. You've got to learn how to multiply. Sorry about that. All right. All right, then multiply this one by 1/4 is a lot easier. 19/12 pi. Multiply this one by 1/4. You may want to do this because Mr. Evans obviously was having trouble himself, and you get 5/3 pi. Okay, you have to, do a little 1/4 there. Now, I'm going to show you what happens if you go ahead and multiply this one by 1/4 because it's just interesting, okay? And if you were to write these down, no one would complain because they're kind of like more than you need. But I'm going to show you what would happen. What do? You take 1/4 of that, you get 25 over 12. What's the deal with that? That's bigger than how much? That's bigger than 2 pi. Because 12 goes into that how many times? 2, and there's something left over, right? So this would actually give you answers bigger than 2 pi. That's why we don't have to go that far. So if there's a 4 there, you've got to go around the circle 4 times. If you go around it 5 times, it's not going to hurt you. You're just going to end up getting answers that are larger than what? 2 pi. Okay? If there's a 3 there, all you got to do is go around it 3 times. If you do go around it 4 times, you're going to get answers larger than 2 pi. All right? Yes, sir?
Okay, so, like, I know we added the 2 pi
Yeah.
to get those. Will it always be adding 2 pi?
Yep. Because every time you go around the circle, how far is that? 2 pi. Yeah. Yeah, there you go. Yeah, and see, if, with the knowledge of the unit circle, I can answer that question. And when you're going around the circle, how far are you going? 2 pi. Now, students that don't learn this end up just putting these first 2 answers. They go around it 1 time, they take 1/4 of those, they put these 2 answers, and that's it. And that's not the whole story. All right? Now, someone says, Mr. Evans, would you do another one of those? Yes, I will. All right?
Can you stop right there, Mr. Evans? That's your whole answer right there.
That is all of the places, those are all the x values where if you substitute them in here and work it out, you'll get square root of 3 over 2. That's right. And that's not all of them, that's just all of them between what? 0 and 2 pi. Yes,
And
sir.
So, like, where it says, like, the square root of 3 over 2 equals, like, the 4x.
That's the equation that's given to you right
And
there.
so will you always, will that always be the y value that you're looking for, or could it be an x value?
Okay, what's the cosine?
The cosine
Is the x values. The sines are the,
y value.
and the tangents are, yeah, you can be asked, oh, well, yeah, let me go ahead and take care of your question right here. I have, oh, I should have erased that because I might have had another question, but here you go. I have tangent squared. Let's see, I have 3 tangent squared 2 theta equals 1. All right. Somebody doesn't even have their unit circle drawn right. And then test 1 because they didn't have a unit circle, Mr. Evans. Remember, tomorrow I'll give you the chance to do the little bonus exam. Some of y'all need it. Some of y'all better bring your unit circle this time in a little bit better shape. Okay, I'm not going to worry about that yet. I could put x equals 2 theta right now, but you don't need to. Let's go ahead and isolate this by itself. Fair enough? Is everybody okay? It's going to be tangent squared 2 theta equals 1 over 3. Right? So, the tangent of 2 theta is going to equal positive or negative 1 over the square root of 3. All right? And those, there should be some of those on your unit circle, right? Okay. So what I'm going to do at this moment, this is when I'm going to say, let's make x equal 2 theta so that we don't have to worry about it yet. And so what we're going to do is we're going to do, okay, tangent of x equals positive or negative 1 over square root of 3. We're going to find the x values. Are you okay with this? I'm making x equal 2 theta so that I can just look for the values. So I look on my circle and I find out where does tangent equal a positive or a negative 1 over the square root of 3. And there should be 4 places.
This is going to take forever to solve the whole thing.
They do, yeah. Yeah, they're not hard, you just have to be willing to do the work. Okay, what are they?
Pi over 6.
How much?
Pi over 6.
Pi over 6.
5 over 6 pi. 7 over 6 pi.
And,
11 over 6 pi.
okay. Now, you notice we only have to go around the circle twice. Because that's a what right there? A 2. Yeah, if this were like a 5 or something, you'd have to go around the circle a whole bunch, right? Yeah, I didn't want to put a 3 there because when I was making this one up, I'm thinking, oh gosh, there's 4 answers. There's 4 places every time I go around. Okay, what am I about to add to these? We'll add what?
2 pi.
Add 2 pi. Okay, that got us around the circle once. Do you see that that got us around the circle once?
Yes.
Now, if I'm going to add 2 pi, that's 12/6 pi. If you need to, go ahead and get your common denominator. See? So that's going to be 13/6 pi right there. That's going to be 17/6 pi. Add it there, it's 19/6 pi. And add it right there, that's 23/6 pi. And the good news is, you can now find out what theta equals. Because if that's what x equals, you really want to know what theta equals, right? Okay, I'm going to stop for just a second, make sure you got that list good. Got to speed up looking at it. I don't want to go too fast. And that got us around the circle twice. And for those people, if your teacher didn't make you learn how to do fractions, which later today I'm going to have some kids that are just going to be crying over the fact that they're having to work fractions.
Oh, wait, hold on. So when you find the numbers the first time, that counts as your first time?
That's your first time around the circle.
Okay, so you're doing one less time.
Right.
Okay.
Yeah. There's 1 time around the circle, and then there's what? 2 times around the circle. And if you do it 3 times around the circle, your answers are legit. They're just not in the interval we're really looking for.
Mm-hmm.
Okay, let's find out what theta equals. Theta equals half of x. Well, it should be pretty easy to take half all those, shouldn't it? Okay, so theta is going to equal pi over 12, 5 twelfths, 7 twelfths, 11 twelfths, 13 twelfths, 17 twelfths, 19 twelfths, and 23 twelfths. And what you'll notice is, see how close that is to 2 pi? That's getting real close to 2 pi right there, right? See, 23 over 12, that's real close to 2 pi. And those would be all of your solutions on the interval 0 to 2 pi. Now, take a look at that, and then I'm going to give the deep thought for the day. The brain thought for the day.
So the bottom would be all the intervals?
Theta equals, that's your thetas. And yours trying to solve for what? Theta. Okay? And if all of your trig, well, let's not even start that statement yet. Make sure everybody's okay with this. Have me on tape making fun of the children.
So it says like plus or minus 1 over square root of 3. Why is it plus or minus and not just negative or? Oh, okay.
You took a square root, and when you take a square root, it is not a principal square root. It is what? Positive or negative. Here is what, to me, is interesting about this, or what makes this really cool, or makes this big thinking, is you notice that your final solutions are not numbers that are on your unit circle. Yeah, your unit circle looks limited. When you look at your unit circle, you think, well, gosh, that's kind of limited there. We didn't put 15 degrees, and we didn't put 22.5 degrees and all that. Yeah, but we put enough information on there that you can get some really precise work and get good solutions without having more information on your unit circle. And there was enough on there to make it very useful. All right. Now, I'm going to make sure everybody's happy with that, and then I'm going to take you to the next, we'll do another problem. Happy over here? Happy? Okay. The next problem, and let's see, all right, here we go. Well, I've got sine 2x minus cosine x equals 0. All right. In this case, this is when it gets a little nasty. See, notice how this one has 2 x's and this one only has x's, right? Okay. You've got to break them down to where they all have just x's. All right? And it's easier to break them down. Somebody says, well, could you make them all have 2x? Yeah, you could. That's a lot harder. So what you do when you see that one of them has like a 2x and one of them has just an x, this one needs to be turned into a case where it only has like sine x and cosine x or tangent x. It needs to be turned into just x's too. Is that all right? When you see this, now if they both had 2 x's, just put theta in for both of them. In other words, if you solve this, sine 2x minus cosine 2x equals 0, then just go ahead and make that theta equals 2x, and then finish working it. Fair enough? And just finish working it. Make it sine theta equal cosine theta, find the thetas, find x. But see, as long as they all have the same value after the trig function, you can go ahead and put theta in and just work it and do what we just did. But when one of them has a 2x and one of them doesn't, that's when you step up. Now, and if you're in a calculus class and you see one of these, sometimes you just cry. All right. You look on the back of your unit circle. And you look for the trig identity. And you will find out that there is a way to make sine 2x turn into something that has sine x and cosine x. What is it? Sine 2x equals 2. Yeah, look on the back. It's on there.
2 sine theta times cosine theta.
Yeah, so we're using x's, so we'll do x. Yeah. And that turns it back into what you were working yesterday and the day before. Yeah. Because now what can you factor out of both of these? Cosine x. Yeah. These to me are the hardest kind because you have to use a trig identity and get to here. All right. Now, is everybody okay? We use the trig identity off the back of our circle. Does everybody have those on their circle? Can you find it on your circle? Everybody point at it on your circle. Point. Point at it on your circle. If you don't have it on your circle is weak.
Yeah, my circle's pretty weak. I don't have it yet.
Okay, you know, I shouldn't show this on my video right here, but years ago, one of my students gave me this. He is now a PhD chemist, and this is what his view would have been for you. Yeah, you just hold on to that a bit.
Yes, sir.
Yeah, don't, yeah, crush the weak. That's what we're going to do. Now, all right, you factor out cosine x. And the factoring is good because it equals 0. Don't try to factor it unless it equals 0. Then you're going to set each one of those factors equal to 0. So you get cosine x equals 0, and you're going to get 2, well, you're going to sine x equals 1/2. And since this is just plain old x here, you don't have to worry about going around the circle multiple times or anything. See, that's the other good news about this, though, is once you got it down to where you're working with just this, by using that trig identity, you don't have to go around multiple times. Okay, where does the cosine equal 0? Look on your unit circle and tell me.
Pi over 2.
Pi over 2, and where else?
3 over 2 pi.
That's right. And then you have to look, where does the sine of x equal 1/2?
Pi over 6.
And where else?
5 over 6 pi.
And that's it. And you don't have to go around the circle multiple times, because once you use that trig identity, you're actually got everything already in just what? X's. All right? So that's what you do when you have where one of them has a 2x or a 3x, the other one just has something like that.
So we have to go around the circle because it was already
We don't have to go around the circle because we've already dealt with that, because we used a trig identity to get it to here.
Okay.
See, we didn't substitute anything in for x. We left it in terms of x the whole time. Are we alive and well out there? All right, now, with that, I had some students say, Mr. Evans, we need some help with some problems that you assigned the other day. And I guess it's a little bit scary that when you have to turn in your trig equations packet that I will have worked some of them for you on the board. Okay, I will look at anything from 6.2 that you would like for me to look at. You got a problem from 6.2, we'll look at it.
Yeah.
25.
35.
25.
25. 6.2, 25. Point 2, number 25.